We should be exploring and learning and seeing and doing all that life allows. Until you learn astronomy, you really have no idea what the whole world, the nature is.
In a photo op nearly a decade in the making, Pluto is ready for its close-up. Just a short time ago, we got the most detailed images ever taken of Pluto, releasing that Pluto is bigger than previously thought, roughly 2/3 the size of the Earth's moon. That's it for now. The Ed Show's up next.
Good evening, Americans, and welcome to the Ed Show.
I don't have a pulse. I just go with what's right.
And Pluto Palooza.
Pluto is getting its close-up.
Here's the image. Here it comes.
I don't think any one of us could have imagined that it was this good of a toy store. Anybody?
This is what we came for.
This exceeds what we came for.
I said a few days before closest approach that there were a lot of smiles because we could feel the momentum, and we're finally getting to the stage where we could see geology and then topography on the surface. But now, I think I could characterize the 4 individual rooms where people are at work as something close to bedlam. Because, and particularly today's probably our biggest challenge. First, we're definitely living on less sleep.
These mountains here that we're seeing were quite spectacular. These are up to 11,000 feet high. We see strange geological features on many of these moons, and we often or usually attribute this to tidal heating, deformation of these worlds by the gravity of that giant planet and interactions with other moons. That can't happen on Pluto. There is no giant body that can be deforming Pluto on an ongoing, regular basis to heat the interior. Charon is just too small to do that. So this is telling us that you do not need tidal heating to power ongoing recent geological activity on icy worlds. That's a really important discovery that we just made this morning. So I know this is just the first of the many amazing lessons we're going to get from Pluto, and there'll be more on Friday. We'll have more of this mosaic to show you on Friday, which is going to show equally amazing things, I'm sure, so stay tuned.
Right, and I'm going to follow up on this same image so we can leave it on the screen for you to enjoy. I'll tell you another couple of implications that we've reached as a result of this discovery. Just to expand on what John last said, which is very, very important, we now have an isolated small planet that's showing activity after 4.5 billion years. We thought this might be the case after Voyager 2 discovered that Triton, orbiting Neptune, also has virtually no impact craters. And now we've settled the fact that these very small planets can be very active after a long time, and I think it's going to send a lot of geophysicists back to the drawing boards to try to understand how exactly you do that. There's another implication.
The most stunning thing about this, well, there's many stunning things, but the most striking geologically is we have not yet found a single impact crater on this image. This means this is a very young surface because Pluto is being bombarded by other objects in the Kuiper Belt, and it's bound craters happen. So we just eyeballing it, we think it has to be probably less than 100 million years old, which is a small fraction of the 4.5 billion year age of the solar system. It might be active right now.
Rick Lovett, freelance. Those mountains look really big. Do you have any theories of how they originated? I mean, are they volcanoes or tectonic? They don't look tectonic.
We have no idea at this point.
You might say something about their heights.
Yes, we mentioned that they're about 11,000 feet high, so and they look to be tens of miles wide. So these are pretty substantial mountains. They'd stand up respectably against Rocky Mountains or other significant mountain ranges here on the Earth.
Reed with CBS News. Dr. Stern, I'd like to ask you a question with no scientific words in it. When I interviewed you before the flyby, and the only prediction you would make was that we would see something wonderful. Have your expectations been met? And what's the most wonderful thing you've seen so far?
Well, I'll give you a technical answer. You think? You think? I think the whole system is amazing, and my prediction, written 20 years ago on a little slip of paper, held in a manila envelope since 1993, was proven right by New Horizons. The Pluto system is something wonderful.
The naive expectation, or naive now in hindsight, was that a world this size just wouldn't get enough heat to really drive this kind of activity. And now we see that it can. Or, like John said, there's a lot of heat in an internal ocean, and as the internal ocean...
The structure of that dark northern region on this photo is so much more... different areas seem to be within that area. Does this inform anything about the atmosphere, the Pluto atmosphere transport thoughts we've been talking about, how this material was deposited on the surface? Thanks.
Yeah, so there's definitely different subregions inside that region, and you can see it in this picture, and if you zoom in, you can see it in more detail as well. There are a number of different theories about what that dark region might be. Really inform that. I'm looking forward to getting the spectroscopic information back from the Ralph instrument.
And another aspect of that I'd add is I think a lot of us are looking forward to the stereo data, because then we can do the topographic reconstruction. If that's a basin, it'll be pretty obvious, for example.
From its formation, that's for a lot more work to decide.
But one thing that we can say for sure is that tidal energy is not at work here, and we know that because Pluto and Charon are in tidal equilibrium. Charon orbits in the equivalent of geosynchronous orbit, and it is also spinning at the same rate that Pluto spins, so there's no significant exchange of tidal energy anymore. That process, according to models, numerical models, took place pretty quickly after the giant impact, very small fraction of the age of the solar system. So that must have all been a long time ago.
John, just to follow Irene's question, the large gash across Charon, is that in any way related to a tidal despinning, or is this plus the smooth areas telling you that there's something churning inside in a relatively recent time, and can you put a date on that yet?
No, we've got to count those craters, and we've got to have better images to do that. We certainly know there aren't very many craters, but in terms of the timing of all this, we'll need the better images that we'll get very soon.
Sir? Chip Reed with CBS News.
And finally tonight, I think if you're not impressed by this, you're a pretty tough customer. You're hard to impress. NASA is celebrating a remarkable achievement today, a historic mission to Pluto. Just a short time ago, NASA released new clear images of Pluto's first ever close-up.
I don't think any one of us could have imagined that it was this good of a toy store. Anybody?
This is what we came for.
This exceeds what we came for.
Pluto is so far away, a radio signal takes about 9 hours to get there and back. From Pluto, the sun appears.
Glad to be on the show.
How much can we learn from a close-up picture?
An awful lot. This is the space spectacular of the decade. We thought that Pluto would be a dead planet, like the moon that is pockmarked. We don't see craters. Look at that. We don't see craters on Pluto. Parts of it are as smooth as a baby's bottom. How can that be unless the surface was resurfaced a few million years ago? We now believe that Pluto is active, geologically active, and that upsets all our understanding of these objects. They're not frozen solid at all. They're probably going to have geysers, volcanoes, and they're geologically active.
How much can we learn from these pictures, and what is the next step? Now, we found out a lot, as you just said, about these pictures, but what would be the next step?
The next step is to go zooming into the comet belt, the Kuiper belt of comets, because out there are dangerous objects which the high school textbooks, because we now have glorious pictures of Pluto which overturn what we thought. Pluto, we now know, is an overgrown comet of some sort. If you were to drag Pluto closer to the sun, it would actually sprout a tail, just like Pluto the dog.
I'm curious about temperature. I'm curious about storms, weather. Is there anything like that? Would we learn from this mission, those kinds of things?
Well, Pluto does not have weather as we know it. However, it does have some kind of atmospheric activity. So we're tantalized by the fact that it violates the usual rules of planetary evolution. We now believe that Pluto may actually be radioactive. That may be the source of energy that drives the resurfacing of the planet. Maybe we'll see geysers, just like we see geysers on some of the moons of Jupiter.
All right, everybody wants to know, life. Is there a possibility there could be life on Pluto?
I don't think so. But first, we have to answer the question, is there intelligent life on the Earth? Obviously not. So is there intelligent life in the universe? Well, we don't see any evidence of that on Pluto yet, but hey, who knows?
Water?
We see...
The most stunning thing about this, well, there's many stunning...
So give a thumbs up to NASA for doing this, and a thumbs up to this video.